Alright, hey guys, this is Thursday, April 30th. So what I'm actually going to do is I'm going to call another audible just to make sure we really get this stuff down, because I want to make sure we get this stuff down before I push it with y'all, and really without having much feedback at the time of these lessons. I don't want to really push too far ahead of you guys, and so I'm going to go ahead and call another audible. We have the time to make this stuff up, and so what I'm going to do is push off the next two lessons, and basically today we will just do 11.7 on page 433, and then we will just do the quiz tomorrow, and that's all we will do tomorrow is the quiz to make sure we have this stuff down before we move on, because I don't want to get too far ahead of you. And so, today let's do this lesson, and tomorrow we'll just do the quiz, and we'll push off on the work on the handout I gave you. We won't do page 435. We will stay page 435 through 441 for Monday and Tuesday of next week. That'll be fine. We'll just cut down a couple of the days at the end, but that'll be fine. I think that's more appropriate than laying this all out right now for you. And so what we're going to do then today is just work through these problems. And so this is basically the exact same thing we've been doing the past 2 days, with the exception that now we're going to take all those numerators we got and we're going to add them together and then see what cancels. And so that's pretty much what's going to happen. And so for this problem number 1, the first thing we're going to do is we're going to have to find that common denominator, that least common denominator. And so you're just going to do the prime factorization of 12, 3, and 4, see which one's the highest one of those is, like we did, and then go from there. So 12, you would do 3 times 4, then 4 you would do 2 times 2. So that means the 12 has a 3, a 2, and a 2. For the 3, you would just do the 3, that's all it can do, so it just stays the 3. The 4 just stays the 4. And so the question is, okay, the highest one, this one has 4 really is 2 and 2. You can bring that down if you want. And so the highest amount of 2's we have is 2. So 2 and 2, 2 and 2, they both have 2. So we're using 2 2's, 2 and 2 as our denominator. And then we have 1 3 here, 1 3 there, so they both have 1, so we can just use 1. And so we're only going to be using 2 times 2 times 3 as our common denominator. Again, 2 2's, 2 2's, so we're just going to use 2 twice. And then 1 3, 1 3, so we're just going to use the 1 3 once. And so basically our common denominator then is going to be 2 times 2 times 3, which would be 12. So if you want to write it like that, you can. And so the idea then is the denominator is going to be 12 for each of these. Okay, so then the question is, what do I do to a 12 to get to a 12? Nothing, it's just multiplied by 1. So you would just multiply the top by 1. So it's just x plus 2. That one stays the same. Okay, the question is, what do I do to a 3 to get to a 12? You multiply by 4. And so this one's missing a 4, so I would do multiply by 4 here. If I multiply by 4 here to get to the 12, then I have to multiply by 4 on the top as well. So you would multiply times 4 up here. And so you would have to do x minus 3 times 4. And so that would be 4 times x minus 3. And then the 3x over here, the 4, what am I missing here to get to a 12? It's 4 times 3. And so then you would have to multiply the top by 3. And so it would be 3 times 3x. Okay? So that's just as simple as that goes. Now we're going to have to actually do the multiplication here to see what combines and if anything cancels. And so 4x times 4 times x here would be a 4x. Then 4 times a negative 3 would be a negative 12. 3 times 3 is 9. So that'd be 9x. And then we just have an x plus 2. Then all of these are under 12 now. So all I did was do the multiplication. 4 times x, then 4 times a negative 3. 3 times 3, then wrote it. Then I can combine them all under one denominator. And so then we're just going to start combining and see how things cancel out. And so first I'm going to combine my x's. So I have an x of 4x, so that's 5x. X plus 4x is 5x. Then I have a 9, so 5 plus 9 is 14, and so that adds up to 14x. Then I'm going to do my numbers. Okay, my numbers are a 2, a negative 12. So 2 plus negative 12 is a negative 10. And so I have 14x minus 10 all over 12. And so that would pretty much be your answer. We could try to see, okay, the 12 and the 14 and the 12 and the 12, all of this has something in common. So notice that all of these have a 2 in common. And so I can divide this whole thing by 2. Basically say 14 will go into 2. So divide the 14 by 2, and that'll be 7x. Divide this by 2, that would be minus 6. Then divide the 12 by 2, and that would be 6. And so all of that would go down to there. And so you can do that, and that would be your simplified answer. So that would work. So that would be basically what you do. So that would be your answer, 7x minus 6. 7x divided by 6. All right. That's that. We'll go to number 5. So number 5, the same thing applies. We have to figure out what our common denominator would be. So I have a 7x and a 3x. So that means the 7 needs to be included. So we have the 7. We have the 3 needs to be included. And then we need a x needs to be included. So that would be our denominator. So our denominator would be basically 21x. So get from 7x to 21x, what do? Multiply by 3. So I have to multiply by 3 up top. So this is really 3 times x plus 2 on top to get us to the 21x on the bottom. So you have to multiply 3 to top and bottom. What am I missing here? I have to multiply by 7 to get to the 21x. And so you have to multiply by 7 on the top. And so that's really 7 times x minus 1. So there's what we have going on. Now I just have to basically see, okay, how can things cancel here? Can they cancel? What do I have going on? And so this is number 5. And so I'm going to go ahead and distribute things through. And so 3 times x is a 6x. 3 times 2 is a plus 6. And so that's 3x plus 6. And then I have a 7 times x is a plus 7x. And then a 7 times a negative 1 is a negative 7. And the denominators are the same, so we can just put that as one denominator. Then I just have to clean up. So looking for my x's, I have a 3x and a 7x. That combines to a 10x. Then I have a 6 and a negative 7. So negative 7 plus 6, or 6 minus 7 will give you a negative 1. And so you wind up with 10x minus 1 over 21x. The 21 and the 10 and the 1 has to cancel from all of it if it's going to cancel. This one over here cancels on each part, and so you could do that. This one doesn't, and so that's just your answer. So 10x minus 1 divided by 21x. All right, moving to 13. We have 2x plus 1 plus 3x plus 2. Our denominators are x minus 5 and x plus 5 respectively. And so my question is, what would be my common denominator? Well, we have to see which factor they have total. And so notice this one has an x minus 5. This one does not. So I have to have an x minus 5 in my denominator. This one has an x plus 5. This one does not. So I have to have an x plus 5 in my denominator. That makes my denominator x minus 5, x plus 5. That would be my denominator, x minus 5, x plus 5. Okay, so then the question is, okay, this one has an x minus 5, so what's it missing? It's missing the x plus 5, so I have to multiply top and bottom by x plus 5. When I do that, I end up with x plus 5 on the top times 2x plus 1. Okay, then I get this one over here is an x plus 5, which what's it missing? It's missing the x minus 5. So I have to multiply x minus 5 times top and bottom. So it'd be x minus 5 times x times 3x plus 2. Okay? Now when I add those together, you can combine those to where they add all together. You just have to be careful with how you're looking at it. So look, let's do it this way. Basically you have the x minus 5. Hold on, let me get more spacing for it. So essentially what we have to do is we're just going to have to FOIL both of these out and see what kind of happens. And so we're going to do x plus 5 times 2x plus 1. So we're going to do x times 2x. So that'll give us 2x squared. Then I'm going to do x times the 1. This is the FOIL method. So x times the 1 gives me the x. Then I'm going to do the 5 times the 2x will give me a plus 10x, and then I'm going to do the 5 times the 1, and that'll give me a plus 10. You can go ahead and combine those in the middle if you want. Basically, we're going to be combining a bunch of stuff anyway, so if you leave it, it's fine. But you can go ahead and combine that x and the 10x and get 11x there if you want. I'm going to leave it for now, just because when I FOIL this, we're going to start compiling it all anyway. And so I'm going to do x times 3x, which is x 3x squared. Then I'm going to do x times 2, which is plus 2x. Then I'm going to do negative 5 times 3, which is negative 15 x. Then I'm going to do negative 5 times 2, which would be negative 10. I did that right. And then basically you're just going to look and start compiling what you can compile. Wait, this is a 5. This was plus 5. And so all of this is over x minus 5, x plus 5. So again, just look at it and see what you can combine like terms-wise. So I have a 2x squared and a 3x squared. So I can combine that, and that could give me a 5x squared. So when I combine those, I'll wind up with a 5x squared, 2x squared plus 3x squared, 5x squared. Then I combine my x's. So I have an x and a 10x, that's 11x. Then I have an 11x plus 2 more x's, which is 13x. And then I have 13x minus 15x, which is negative 2x. So again, you're just combining it. Like I said, if you combined them both at this step originally, you're just dealing with two different, you're just combining them differently, but basically you're just combining all the x's, so you can leave it. So minus 2x, and then I can do the number, so I have a positive 5 minus 10, and so that would leave you a negative 5. So your final answer then would be 5x squared minus 2x minus 5 over x minus 5, x plus 5 times x plus 5 on the bottom. So again, a lot of work, it is. It's a little bit tedious, it is. But all you're really doing is you're finding the common denominator, saying, okay, we'll multiply the one that is missing, and then you actually have to FOIL it out, and then combine the like terms, which we've all done before. We're just taking everything we've done, really, and putting it into one problem. And so you just have to be aware of that and be able to do it. So that would be how you do that one. All right, I will go over, I'm going to have to erase it, and then I'm going to do 31. So 31 says x plus 6 over x squared minus 9 minus x plus 4 over x squared plus 2x plus 1. Again, what we're going to do is we're going to figure out first what our common denominator is. So I have to factor x squared minus 9. So if I factor x squared minus 9, I can do it a couple different ways. You can do guess and check with getting the 0x in the middle, or you can just set x squared minus 9 equal to 0. Add 9 to both sides, and get x squared equals 9, square root both sides, and so you have x equals plus and minus 3. That means one of those factors is going to be x minus 3, and one of those factors would be x plus 3. So right now, this can factor to x minus 3, x plus 3. The next step, again, that was just moving it over, square rooting both sides. The next one I'm going to have to factor as well. So I'm going to have to factor x squared plus 2x plus 1. I can do guess and check with that pretty easy. It'd be the factors of 1, same signs that add up to the 2x. And so it would be plus sign, factors of x squared are x and x. Factors of 1 are 1 and 1. And so that would be the two factors that give you that. And so notice my four factors then. I'm going to have 4 of them. So my denominator here, would be x minus 3 times x plus 3 times x plus 1 times x plus 1. So those would be my 4 factors. And so the question then is, okay, what am I for this x squared minus 9, what's it missing? It's missing the x plus 1, x plus 1. And so that means on the top, I have to multiply the top by x plus 1, x plus 1. So I have to multiply this times basically x plus 1 squared. So I have to do x plus 6 times x plus 1 squared for that one, because it's missing both x plus 1's. Then the minus sign, I'm going to go ahead and deal with and distribute this through first of all. Make that plus, change all the signs. Then this one, the denominator for x squared plus 2x plus 1, what's it missing? It had the 2x plus 1's, and so it's missing the x minus 3, x plus 3. So you have to multiply this times x minus 3, x plus 3. So then you have to multiply the top by x minus 3, x plus 3. Okay? Now, there's a little cheat step here. Instead of having to do it verbatim, basically all the way through, you can kind of just use what you originally had. Because notice on the top now, what I'm supposed to do is do x plus 6 times x plus 1 squared. The x plus 1 squared was really x squared plus 2x plus 1. So instead of having to FOIL it back out, you can just really use the x squared plus 2x plus 1 that you originally had for this right here. So the reason I want to write it like that is just simply so I don't have to FOIL it back out. If you FOIL it back out, you just get back to where you started. So just think about it. If you're doing x minus 1, x plus 1 times x plus 1 times x plus 6, basically you're going to have to FOIL these two, and then you would get back to where you started, and then you would have to multiply the x and the 6 through. And so it's easy if you understand what you're seeing, just to say, okay, I multiplied this by x plus 1 squared. That was really just this. And so you can just go ahead and plug that in instead of the x plus 1 squared. Again, it just saves you one extra step. So that may be what you want to try to do. So all of that is over our, basically our x plus 1 squared and our x minus 3, x plus 3. So that was that one. Same way with this one over here. We had x plus, so we had a plus, so we had a plus x minus 4 times x minus 3x plus 3, but x minus 3x plus 3 was really the x squared minus 9. So I can go ahead and go back to that step just to save me the extra step of having to multiply together, because I already know that's what it's going to go back to. And so for this one you can do that, so it'd just be x squared minus 9, and that's really the same thing as the x squared, x minus 3x plus 3. So it just saves you that extra step, just going back to the original. Okay, so now that's halfway through. Now what we have to do is actually do the multiplication. So since we already wrote this, the x plus 1, we already wrote that as the trinomial instead of the binomial that we had to multiply. Now we're just going to distribute the x through and distribute the 6 through. And so here we go. We're going to distribute the x through. I'm going to need a lot more board for this one. So I'm going to go ahead and erase this other stuff. So you're going to distribute the x through. So when you distribute the x to the x squared, you wind up with x cubed. You add the exponents. Then you're going to distribute the x to the 2. And so x to the 2 would be basically just the 2. 1 times 2 is just 2. But then you have to do the x times the x. So you add the exponents. So that would be 2x squared. Then we have to do the x times the 1. And so the x times the 1 would just be a plus 1x. Again, it's a long problem, but it's really not difficult, so don't just freak out on me. If you freak out on me and don't do it, then there's no really sense for it. You can do the math, just have to stick with it. Okay, that got the x through it. Now we have to do the 6 through it, so we have 6x squared. 6x squared. And then we have to do the 6 times the 2, which is 12x. Then we have to do the 6 times the 1, which is plus 6. Again, I can go ahead and see y'all's faces go now on me. Then we're going to do the plus. So then here, it's the same way. You're just going to be distributing it through. So I'm going to do the x times the x squared. And that is going to be minus, that's going to be x cubed. So plus x cubed. Then I'm going to do the x times the 9, which would be 9x. Negative 9x, since it's a negative 9. Then I'm going to do the negative 4 times the x, which is negative 4x squared. Then you're going to do negative 4 times negative 9, which is negative 36. So again, that entire thing took up the entire length of the board. So it is going to take space, but it's not difficult, it's just multiplication, and then we just have to clean it up. So all of that is over our x plus 1 squared, x minus 3, x plus 3. Alright, now we just have to clean up. So I have an x cubed. I'm looking for another x cubed. I have another x cubed here. That's all I have. And so that is 2x cubed. Then I'm looking for x squared. So I have 2x squared. A 6x squared, so that's 8x squared. Then I have a negative 4x squared. So that's 8 minus 4. So that's 4x minus, so that's 4x squared plus 4x squared. Then I can do just my regular numbers. So I have regular x's, so I have a 1x, a 12x, that's what, 1x, 13x. 13x minus 9x is negative 4x. And then I can do my just plain numbers, which would be the negative 36. And then all of that would be over x plus 1 squared, x minus 3, x plus 3. And so this was, that would be your answer. So again, you can try to kind of separate it out a little bit. You can kind of see, okay, can I factor anything out of any of this? Notice that there is a 2 in common here, and so you can kind of factor the 2 out. But outside of that, that's about all you can do. So that would be your answer. That's as far as you can get it. So again, that took up pretty much a lot of stuff, but it's not really that difficult. It just takes a bit of time, and you have to stick with it. And so that'll be our lesson today. I just need you to do 1 through, basically do 1 through 34. Try to get as many of them done as you can. I know they're long, so if you want to do, I'll do this for you. I'll do 2 through 34 even. That way, since they're long, so you only have to do 2 through 34 if you watch the video. So 2 through 34 even, and tomorrow we'll take the quiz on it. So y'all have a good day.